Welcome to the Explainer. If you've ever wanted to get into Python but didn't know where to start, you've come to the right place. Seriously, in the next 5 minutes, we're going to tear through the 5 fundamental concepts that power pretty much every Python program out there, giving you the foundation you need to actually start building your own stuff.
So here's the game plan. First, we'll check out the basic ingredients of any program. Then we'll figure out how to make our code actually do something. After that, we're going to give our code a brain so it can make decisions. And finally, we'll see how to manage big batches of data without losing our minds. Let's get into it.
All right, part 1, the basic ingredients. Every single program, no matter how ridiculously complex it seems, really starts with one simple idea, a way to hold on to information. In programming, we do this with something called a variable. Just think of a variable as a labeled box. That's it. We can have a box we labeled age, and we just pop the number 21 inside. Or maybe a box called username, where we store the name bro. From then on, whenever our code sees that name, Python just looks inside that box and uses whatever value it finds. It's really that simple. So that kind of begs the question, right? What sort of information can we even put in these boxes? Because, a word is totally different from a number, and Python needs to know how to handle each one. These different kinds of info are called data types.
This table right here breaks down the 4 heavy hitters. First up, you've got strings. That's for any kind of text. Then you have integers for nice, clean, whole numbers, and floats for any number with a decimal point. That difference is actually pretty important for doing math correctly. And last, we've got booleans, which are the simplest of all. They can only be true or false. That's it. These 4 types, they're the bedrock of pretty much all data in Python.
Okay, so storing data is cool and all, but it's not super useful on its own, right? Let's jump into part 2 and see how we can make our code actually do things, like, talk to a user and run some calculations.
The input function is basically your program's way of talking to the world. It stops everything, flashes a message on the screen, and just waits for the user to type something in. Now here's the one thing you have to remember. No matter what they type, even if it's a number, input always grabs it as a string, just a piece of text. That little detail is super important.
So once you have some numbers to play with, whether you got them from the user or just to find them yourself, you can finally start doing some math. And to do that, Python uses these really simple symbols we call arithmetic operators.
And this is your essential math toolkit. You've got the ones you'd expect, plus, minus, multiply, divide. But then there are 2 really powerful ones, the double asterisk for exponents, to the power of, and the percent sign for something called modulus. Modulus just gives you the remainder after division. Sounds weird, I know, but trust me, it's incredibly useful for things like checking if a number is even or odd. Okay, so our code can hold data, and it can do math. Now for the really fun part, in section 3, giving our program a brain. This is where our code stops being just a dumb list of instructions and actually starts making smart decisions and repeating things on its own.
The if statement is the most basic kind of decision-making in your code. It just asks a simple true or false question. If the answer's true, boom, it runs a specific block of code. If the answer's false, it just skips right over that block and keeps on going. But what if you want something to happen when the condition is false? Well, that's what else is for. You can see it in this example. If the age is 18 or more, we run 1 bit of code. If it's not, the else block kicks in and gives us an alternative path. It's just a simple fork in the road for your program to follow. Now, what if you need to do something again and again and again? This is what computers were born to do. Instead of you writing the same line of code 100 times, we can just tell the computer to repeat it for us by using a loop. And this is a really key insight. Python gives you 2 main kinds of loops for different jobs. A while loop keeps running as long as some condition is true. It'll just keep going and going. A for loop, on the other hand, is for when you want to run code a specific number of times. Choosing the right one is a huge part of programming well. Let's just trace this for loop to see exactly what's happening. The range 1 for part is a little tricky, and it trips up a lot of people at first. It means start at 1 and go up to, but don't include 4. So on the first pass, x is 1, and we print it. Second pass, x becomes 2, we print that. Finally, x is 3, we print it. And since the next number would be 4, our stop sign, the loop just ends. And that brings us to our final section, handling data when you've got a lot of it. See, so far, our variables have been like these little boxes holding just one item. But what if you have a whole shopping list or a classroom full of students? You're going to need a bigger container.
So instead of making a variable called fruit1 and then fruit2, fruit3, which would be a nightmare, you can create one single variable, like a basket, that holds a whole collection of items. In Python, the most common way to do this is with a data structure called a list. A list is just an ordered collection of things. You make one with square brackets, and you just separate your items with a comma. The most important things to know are right there in the definition. The order you put things in matters. You can change it later by adding or removing stuff. And yeah, you can have duplicates. It's super flexible and powerful.
And there you have it. Variables, operators, if statements, loops, and lists. These 5 concepts are the fundamental tools, the building blocks, you'll use to build pretty much anything you can imagine in Python, from a tiny script to a huge application. So I'll just leave you with this question. With these 5 building blocks we just talked about, what's the first simple program you would want to create? Think about it. A basic calculator, maybe a little app to manage your grocery list, or even a simple guessing game. You now have the toolkit to start building it. That's the real power of these fundamentals.